All right, guys, so I already did uh, a lesson on kind of the background of classifying quadrilaterals and one full example. That video is getting a little long, so I decided to kind of cut it there and do maybe a bonus video here with two more just straight up examples. So again, if you didn't watch those, you need to go back and watch those first so you kind of understand where we're going here. So second example, we did one example up above. Here's number 2. Determine if the quadrilateral with the given vertices is a rectangle. So first thing we need to do is plot those points. So -6, 2, that's point L. M is -4, -1. N is 2, 3. And P is 0, 6. So we plot our 4 points. Kind of shade it in here so we can see it a little bit better. And now we have to do our investigation. So remember, determining if it's a rectangle. So that means we have to look and see does it have 2 sets of opposite parallel sides? Because if it's a rectangle, it should. And then I have to look and see, does it have, let's say, does it have 4 90-degree angles? Right? And the way we determine if it has 4 90-degree angles, do all consecutive sides have opposite reciprocal slopes? So in the last problem, I did a full workup of this problem, right? I found the length of all the sides. This time I'm going to kind of just zero in on what we really need to do for this problem, right? So to determine the specific classification, we do need to find the length of the sides. Okay, if it's just asking me if it's a rectangle, then these two things here are enough, because if those are true, then the side lengths or opposite sides are going to be the same no matter what. So 2 sides of opposite parallel sides. So let's kind of draw in our triangles. So let's go with our little slope triangles here. So we have LM, right? LM, the slope from L to M. So this side right here in purple, right? To go from L to M, I have to go down 1, 2, 3, and to the right 2. So 3, down 3, right 2. So my slope is -3 over 2. From M to N, do that in orange. So from M to N, and I'm going to draw in a triangle. Remember, we always go up or down first, so it's going to go up 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6. So 4 over 6, that was MN. The slope was 4 over 6. And I can reduce that fraction to 2 over 3. The third side, N to P, right? I'll do that in pink. Draw in my triangle. Remember, we always go from left to right. And it's going to go down 1, 2, 3, and to the right 2. So NP, the slope went down 3, right 2. And my last side, I'll do that in blue. Draw in my triangle, right? Going from left to right, it's going to go up 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6. Right is a positive direction, up is a positive direction. So for PL, my slope was 4/6. Again, I can reduce that fraction to 2/3. So is this a rectangle, right? So first question I have to ask myself is, does it have two sets of opposite parallel sides? So if I look, right, the slope of LM, so the purple side, and NP, the pink side, those slopes are the same. MN and PL, the two long sides, those slopes are the same. So does it have two sets of opposite parallel sides? Yes. And then I have to look to see, does it have 4 90-degree angles, right? And the way I can tell is if all the consecutive sides have opposite reciprocal slopes. So as I look from LM to MN, right? So I just went around the triangles from the purple side to the orange side. So from there to there, are the slopes opposite reciprocals? Right? So -3/2, if I flip that, I get 2/3, and then change the sign will become positive. And that is what I have in MN, right? And if I go from there to there, if I flip it and change the sign, does that work? So flip 2/3, I would get 3/2 and make it negative. So that worked, right? From there to there, flip it and change the sign. Yep. And then I have to double check when I go from there back to the beginning, right? Flip it and change the sign. Yes. So all consecutive sides have opposite reciprocal slopes. Yes. So that tells me this is a rectangle. Right? And you can see I actually did it without finding any of the side lengths, because if the opposite sides are parallel and they're all 90-degree angles, they're going to have to be the same size. So understanding like what information precisely you need to answer the question. If this just said find or classify this quadrilateral, you would need to find the side lengths first. That would be the best way to do it. Just to be sure. I mean, you can probably tell by looking at this one, it's not a rhombus, that they're not all the same size, but you want to make sure. All right, so we got one more video in our bonus coverage here. I think, yep, there it is. Example number 3. A little bit slow there. So name the quadrilateral with the vertices. Okay, so this one does not ask me specifically, like, is it a rectangle? So I am going to need to find the lengths of the sides. Again, I could do this with the distance formula if I like formulas, and probably math too, that's not a bad strategy. But for now, we're going to just do it all on the graph. So vertices A, -2, 1. So -2, 1 is A. 1, 4. So 1, 4 is B. 4, 1 is C. And 1, -2 is D. So A, B, C, D, and then finish it back up. Okay, so the first thing we need to do is find the length of all the sides. So we're going to go ahead and find the length of, let's color coordinate these a little bit. So AB, let's kind of find the length of AB. We'll do AB green, right? So we'll go up 1, 2, 3, and to the right 1, 2, 3. So AB 3 squared plus 3 squared equals C squared. Right? C is the hypotenuse. 9 plus 9 equals C squared. 18 equals c squared, and I want not c squared, but c, so I take the square root of both sides. And for right now, we're just going to leave it like that. In Math 2, you'll learn how to simplify that a little bit more. So that's the length of side AB. I can also find the slope while I'm working on AB really easily. So from A to B, it went up 3 and right 3. So 3 over 3. And I'm just going to leave it as a fraction, not make that a 1, just because it'll be a little bit easier to see when we talk about reciprocals and stuff when it's written as a fraction. So then I'm going to look at the next side, BC. So from B to C, it goes down 3, right 3. So I don't really need to worry about the length of my, the sine of my triangle. I'll put it in there, negative 3 squared plus 3 squared equals c squared. Negative 3 squared is 9, right? So remember, when the lengths get squared, the negative is going to end up vanishing, so that's a nice thing. So 9 plus 9 equals c squared. 18 equals c squared. C is the square root of 18, so that's a nice thing. I see those two are already the same, so that's good. And let's find the slope. So the slope of BC, right? It went down 3, right 3. I got a fourth side here. We'll do it in, or third side rather, in blue. So from C to D. So from CD is going to go like this. And remember, we like to go from left to right. That's an uphill slope from left to right, so it's going to be positive. So it's going up 3, right 3. So I have 3 squared plus 3 squared equals c squared, right? This should look familiar by now. It looks like the green one, right? So same numbers, going to give me the same result. Square root of 18 is going to be the length of that side. So far, 3 of them are the same. That's nice. And my slope of the blue one, it's going uphill, so I know it's going to be a positive slope, 3 over 3. And my last, see what color I haven't used yet. Kind of gold color here, I guess. So we'll go on this one. So my 3 over 3, and it's going downhill, so I know that the vertical has to be negative because we go up or down first. So from A, B, C, D to A, I have negative 3 squared. Make sure I go like this, but it's not going to work. Plus 3 squared equals c squared. Right, that looks just like the orange one. So same numbers are going to give me the same result. And my slope for that one's going downhill. My yellow one's going downhill. So negative 3 over 3. So we did all the work. Now we have to make a determination. What exactly is the classification of this shape right here? So get my highlighter out. First thing we looked at was our opposite sides parallel. So let's look at the green and the blue side, A, B, and C, D. Are they parallel? Well, if I look here, the slopes are the same. So those are parallel. Then I'm going to look at the other two sides, the orange and the gold. Are those parallel? So the orange, negative 3 over 3, and the gold, negative 3 over 3. Those are parallel too. So it has two sets. That way I know, so I can start off by saying, all right, so far I know it's a parallelogram. All right, so my computer's gonna, all this writing slows down the screen, so I don't want to scroll all the way back up, but that's the first thing we knew, right? It's a parallelogram, not a kite or a trapezoid, so it's a parallelogram. Then we have to look and see, is it a rhombus or a rectangle, right? So we're going to look to see, is it a rhombus? That means all four sides are the same length. So if I look here, the lengths are all the same. Then we look and see, is it a, just gonna make a little note here. Right, rhombus had 4 congruent sides, so it is a rhombus. Then we're going to look and see, is it a rectangle? Right, that means 4 90-degree angles. So remember, we checked to see if the angles are 90 degrees by looking to see if, as I go this way, the slopes are opposite reciprocals, the consecutive sides. So 3/3, if I flip it and change the sign, I end up with -3/3, so that one was good. -3/3, if I go to the other side, I flip it and change the sign, that one's good also. Right, it's just going to keep doing the same thing, right? Flip it, and then I have to check as I go back to the beginning. If I flip it and change the sign, it worked. So it does have 4 90-degree angles because all of the slopes as I go around consecutive sides are opposite reciprocals. So it is a rectangle. So if a figure is a rhombus and a rectangle, we saw that means it's a square. So these are not short problems. These are actually, pretty lengthy problems by Math 1 standards that requires a lot of work. We've got to use Pythagorean theorem. We got to use our slopes. We got to use our knowledge of perpendicular lines and segments having opposite reciprocal slopes, and then putting that all together to classify shapes. So these are pretty comprehensive problems. It does require a lot of practice. So take advantage of these kind of notes and practice sessions here to get better acquainted with these. These are definitely a lot of geometry in Math 2, so we want to be kind of feeling good about our Pythagorean theorem and our slope stuff as we go into Math 2.